Hi students, let's look at this question here which is on vectors. Let's see if I can do this proficiently. So this question is on a cuboid. It's taken from one of the ACJC tutorial questions. So the diagram shows a cuboid of OABC and A prime, B prime, C prime, in which the length of OA, OC, OD prime are 3A, 2A, and A. So I think just first thing is just to label them, the length here. Then you have 2A. This is the length. This is not the vector. So OC is just 2A. And the height here is A. Okay, so if this is a cuboid, we know that the opposite length here are the same. Alright, and the height here, they're all the same length at the side here. Okay, so I'm just going to label them down first. The next thing what we'll do is, okay, the point O is taken as the origin with unit vectors I, J, K. Okay, this is important. Please pay attention here. OA is I, so this is 1 unit here. So this coordinate system, this would be I. Pointing here, this is positive I. Then OC is J. OC is J, meaning this is J over here. And here, pointing outwards here, is K per unit, right? So typically we point outwards as K. So that's the whole point there. Now the point P on C prime, B prime, and Q. So P is somewhere here. I'm not sure where is it. P is here. And Q is here, somewhere here. Okay. So but we're given the ratio here. So remember in class what I mentioned is try not to read off the ratio like that. It's going to be very confusing. So sometimes students get confused how to write this out. So I will suggest rearrange this CP, C B prime as a third. Okay. So you know that C prime P will just correspond to a unit length, and C prime B prime correspond to three units. All right. So C prime P is 1, so this will just be 1 here. This is 1. Okay, then this would be 3 units. Okay, maybe this is so this is 1. This whole thing here is 3. Okay, so it's a ratio of 1:2. All right. So just remember that. I'll just repeat this. This is 1 and this is 2. This is 1 and this is 2. 3 units. So in turn, this will give us 2 units here. Alright, so that's 1. Then after which we're going to do the same thing for OQ, OT. OQ is OD prime is equals to 1/3. OQ is 1 unit. OD prime is 3 units. So OQ is the same thing. So basically this is a Q will be here. So this is 1. This is 3. So that will be 2 on top. Okay, great. Now find the position vector of P and Q. Okay, great. So it's not. So we're going to just find first one. Now we know that OD prime is just 0, 0. Now take note, OD prime, because you're moving A units upwards. So this is just you're not moving 0, 0. You don't have any IJ components. You just go up. So by going up, you have 0, 0 component here. Then this will be A, 0, 0, A. Okay, the position vector here is 0, 0, A. For this case here, this is 3A. So because you move I, but 0, 0, then this B here is good to just label everything that you quickly. So this is 3A, and you move 2A in this direction. So you move from here, 3A, and this is 2A, right? So in other words, this column vector here is 3A, 2A, and 0. So reading the column vector, the position vector is important because I think sometimes you need to get used to it. It's exactly like reading Cartesian form in secondary school, just that now you have more things to. So it's 3A, 0, because you don't have any J component, 3A, 0, and A. Alright, so, and then I'm going to just label this as 0, 2A, 0, and this is 0, 2A, and A. So I label everything that I need. So now I could do what I need to do. So I have all this. I'm going to do with P first. So by ratio theorem, okay, I know that now here, this is an interesting bit. So OP is, remember by ratio theorem, this over here is actually a triangle. Do you see that this is like a triangle? So the the idea here is essentially we going to just this area here. So we're going to take the vector in the middle here. Okay, it's always a subject. By ratio theorem, this is always a subject. So OP will be equals to, so you take OC cross multiply, right? This is 2, and this over here cross with 1. So OC prime times 2 plus 2 times 1, then 1 times OB prime. Then you add both ratio up together, which is 2 plus 1. Okay, so ratio theorem, remember the middle person is always the, what do you call it? The subject by ratio theorem. So there you go. I got this, and I need to just write 2OC prime. OC prime is 0, 2A, 0, 2A, 0, 2A, and A. So 0, 2AA. Plus OB prime is 3A, 2AA, 3A, 2AA, and 3. Okay, so we add everything up nicely here. What we'll get is this is 3A, this is 6A, then there'll be 3A divided by 3. So this will just be divided by 3 throughout. This is A, 2A, and A. Okay. So that is our, what do they want? They want the position vector. So A to AA. So we can leave it as a column vector, or just write it down. OP prime is A I plus 2A J plus AK. Great. So this is OP. Then we're going to look at OQ. OQ is actually, where is OQ? OQ is the easiest. OQ is just basically secondary school stuff. OQ is just 1/3 of OD, right? So this is 1/3 of OD prime. So that will be 1/3. OD, we already list up AA 00A. So this is just this is OQ, which is actually just 1/3 AK. Okay, is 0I. So I think that's pretty okay. That's OQ. Alright, let's look at the second one. So the second one should be quite straightforward. Hence, find the vector equation of line PQ. PQ, we need PQ. So now we have P and Q. I've already got P and Q, so I'm going to find this line here. So it's P to Q here. Okay, so I hope you can just visualize this line here, P to Q. Now P to Q, you need two position, as in two points to form a line equation. That is what we know. It's very quickly we can just write down the line PQ is actually just R. Then you can just use either OP or OQ, it doesn't matter. So you can, I'm just going to use OQ maybe. So O00. Then this is 1/3 A. 1/3 A. Okay, plus lambda P to Q. Okay, P to Q. I'm going to just find P to Q. This is a direction vector. So a direction P to Q is just Q minus P. So this is 0, 0, 1/3 A minus of A to AA, which is actually just negative A, negative 2A, and negative 2/3 A. We can just multiply with negative 3. That will be 3A, 6A, and 2A. Okay, so it's 362A, but A is a constant, so or we could just multiply with 3 over A, because the A is just redundant, so the direction will just be 362. Okay, so this case here will be 362, where lambda is real value. So you can just use this as your, sorry, this A is, I'm very used to, it's a constant, so it's A over 3. Okay, yeah, it's not a vector here. You can leave it like that. You could also write in this, you could just use OP as well. Now you can't simplify A here, okay? You can only simplify A here because this A absorbed in this lambda will be another lambda, which is actually a real value as well. Okay, so let's look at part 3. So part 3, determine whether PQ and AC prime are skew lines. So I think the first thing, PQ and AC prime. Where's AC prime? Okay. So the question now is whether they are intersecting or not, right? So we going to just find the AC prime, the line AC prime first. So first thing is I'm going to write is part 3. I'm going to take my OC prime is actually just, what was it? 0, 2A and A. And after which we have what line do we need? We need OC prime, OC prime and A. A is 3A 0, 0. Okay, so OA is just 3A 0, 0. So now I'm gonna find line of AC prime. That's pretty okay. We can just use OA here, 3A 0, 0 plus mu. Okay, so now we're gonna use mu. So this case here, AC prime here would just be just take a normal 0 to AA. 0 to AA. This one, I think I'll just use OP here because it's easier. I don't want to use fraction. So this is A to A and A first. We're gonna do this A prime. This is 0 to AA and 3A 0, 0. Negative 3A, 2A and A. Great. Okay, so this case here, divide by A because A is a constant, minus 3 to 1. So this is minus 3 to 1. And this is mu real value. Okay, so the question now is whether LAC and L, what line was it? PQ, they are skew or not. Alright, so we're going to write now PQ, this is R equals to PQ, just be A to A and A plus lambda 362, lambda is real. Okay, so we know that DAC prime not equals to direction of PQ. So they basically, okay, maybe this is K. K is a real value. So essentially they are non-parallel. So they either be intersecting or skew, or intersecting or skew, yeah. So what we're gonna do is just let LAC equals to PQ. You just need to find the intersecting point. So I'm gonna just equate both of this. Okay, remember, in secondary school, we usually just let Y1 equals to Y2, right? So the question now is whether Y1 and Y2, you will have, what do you call it? You have a common mu and lambda which satisfy both line equation. Okay, but that is the thing. Okay, for this case here, you realize that this is 3A minus 3 mu so A plus 3 lambda. So I'm going to take the x out. Okay, then I'm going to use 2 mu equals to 2A. This is 362, sorry, 2A plus 6 lambda. And this is mu equals to A plus 2 lambda. That will give us 3 lambda plus 3 mu equals to 2A. And then 6 lambda minus 2 mu equals to minus 2A. And then 2 lambda minus mu equals to A. Okay, so the question now is whether you have a lambda which satisfy all these equation here. You have three unknowns here. Okay, you have actually 2 unknowns here. So what we're going to do is actually just solve for lambda and mu, which see whether it satisfies all the equation here. So I'm going to just substitute. Let me see first. Let's just try and solve these 2. So we solve these 2. So 1 and 2, solving 1 and 2, 1, 2 and 3. So solving 1 and 2, right? So we're just gonna take 1 multiplied by 3, or maybe just multiply by 2. That's good. 1 multiplied by 2. We just take I'm going to use elimination. So 3 multiplied by 2, then that will give us 6 lambda plus 6 mu equals to 4a. And then you have 6 lambda minus 2 mu equals to minus 2a. So this is, so you just take this. This is 2, right? So 4 minus 2, 6 lambda, this will be 8 mu. This will be, minus will just be 6a. So mu is equals to 3, 8 mu, 608, that will be 3 over 4a. Then lambda, on the other hand, would sub into any of it. So because we are solving these two, so just make sure that you take mu and sub into any of it. That will give us, I'm just going to do it quick, okay? So minus 2 plus 2 times 3 over 4. There we go. Minus 2 plus 2 okay, so this will be, I'll just sub into 2 here to solve. Minus 2 divided by 6, that will give us minus 2 plus 12a. Okay, so we just gonna sub mu equals to 3 over 4 a and lambda equals to negative 1 over 12a into left hand side of 3, and hope that we get a. If we get a, means you satisfy all the 3 equations with this lambda and mu. If not, then it has to be a skew line. No, they both have, they are skew. So this will be left hand side would just be 2 minus half a minus 3 over 4a. That will give us minus 3 over 4, that will be negative 11 over 12a. Okay, so not equals to right hand side. Okay, hence lines are skew. Okay, they are skew lines. That's about it. That's part 2. Yep. So meaning they don't intersect, they are actually is like slightly below. So if you think about it, it's actually below it. It's not like intersecting. That's how you do this question here. Let's look at part 4. Find the shortest distance from M, the midpoint AB prime to the line PQ. AB prime to the line PQ. Find the shortest distance of M, the midpoint of AB prime. Where's AB prime? AB prime is here. Okay, this is AB prime. So you have the midpoint here, which is actually M, to the line PQ. I think it's pretty okay. Now, when it becomes more and more complicated, what I'll suggest is you just take the point out and the line out. That's all. The relationship now is just between a point M, which you can find, right? You can just use ratio theorem and find it because it's just a midpoint here. You can find it using the midpoint. Then you just take the line PQ out. Then you can actually find the shortest distance. All right. So we're gonna just do by using ratio theorem. So this is part 4. Sorry. So by midpoint theorem. Okay. So OM will just be equals to, remember, OM is a middle point, midpoint here. So it will be the subject. OM is OB prime times 1, OA times 1 divided by 1 plus 1 because this is ratio 1 plus 1. So by ratio, it's actually ratio theorem. So this is OB prime plus OA, okay, divided by 2. So I'm gonna just replace OB prime and OA in. I think it's not an issue there. OB prime is 3A, 2A, and A, right? So this is 3A, 2A, and A. OA is actually just 3A, 0, 0. So this is 3A, 0, 0. And this is divided by 2. This will be 6A, 2AA times half. Okay, this is OM. So now what we need now is the shortest distance of So I found OM already, to the line PQ. PQ is this line which we found, so I'm gonna just draw the line PQ out. It doesn't really matter, okay? So just draw it out. So this is PQ, line PQ based on my formula here, which I use with A to AA. So this is P, right? A to AA that's P, right? I believe, yeah. A to AA and 362. 362 as the direction here. Okay, then you have got M here, which is half of it. So I'm gonna just put this as 6A to AA. Okay, so if you want to find the shortest distance, remember, just draw, because now you have the vector of P to M. That is important. Then after which you have this direction here, which is this one here. All right. Now what we want is actually that distance here. So anything to do with distance, use the metric triangle. So this case here, the angle between these two vectors will be here. Okay, now we don't really care whether it's obtuse or acute in this case, because the distance between them is essentially just modular. So we can just use this as PM, okay, cross or dot. So this is opposite. Opposite will correspond to cross product. Opposite in secondary school we learned this is sine. Okay, sine will correspond to cross. Okay, so this will be cross 362. Just take the two vectors and cross it, but you do not unit vector. Okay, the direction vector here is this is D, so this is D. Then you don't unit vector the hypo, you unit vector the direction here. So that's about it. So the shortest distance would then just be PM dot with the unit vector. Okay, so I'm gonna just I think PM should be quite okay. PM side quest a bit. Just do the normal. This is 3A. PM is OM minus OP, right? So this is A and half A minus of A to A and A. That will give us 2A, negative A, negative half A. Alright, so PM would just be 2A minus half A dot with 362 unit vector, so divide by its own length, 62 plus 2 square. Sorry, cross product. What am I doing? Okay, so I'm going to do cross product. Hi, goodness. It's cross product. 3 square plus 6 square plus 2 square. That will give us 49. That's a very nice number there, because it's a perfect square. I'm going to do a cross product for the vectors on top. So this is minus 2 plus 3, that will be A. Then we got 4 plus 3 over 2. This cross product. So I am just doing a normal cross product here. If you're not too sure, please refer to this. You're supposed to know how to do it, so I'm not going to explain this part here. So if you want to mod the this part, this will just be this is square root square plus 11 over 2a square plus 15a square over 7. Wow, that will be 1 plus 11. So I'm not sure whether we need to find the exact value there, but we could just leave it like that. So plus 11 is not square plus 15 square there. That will be this is 1 over 7, and this will just be 1025 over 4 a square. Of course, 10, this will just it hurts. Oh my goodness. Okay, this is so painful to watch. So I'm going to simplify this. So you can root the root 4 below. You get 1 over root 4, and you just root the. Okay, maybe I shouldn't skip like that. Maybe I just put it like that. This is root 102425 a square root a square root a square is a. So That'll be good. 1025, we can try and see whether it could divide. Oh, there you go. Can divide by 25, which is a perfect square. That will be this is 2. 7 times 2 is 14. So perfect square, 25 and 41. So this will be 5 over 14. 5 over 14. Square root 41. Okay. So there you go. That's how units. So I'm going to put this as units. So that's how you do this question here proficiently. If you have any question, please let me know. I think this is the part here. Great. Let's look at the subsequent part. So let's look at the last part here. Use vector product to find the area of PQM. PQM would then be, where's PQM? Where's PQM? Okay, we have M, we have PQ and M. Okay, I got Q, I got M. Okay, I think it's a pretty okay question here. It's not like, because we have all the position vector of PQM. Same thing, try not to visualize from this cuboid. It's going to be very confusing. What you actually need are just the 3 points. So I'm just going to list down the 3 points out. So here, what I need is 3 points PQM. So I have M. I've got Q and M. So M is half something. Let me check. M is actually half 6A, 2A, and 6A, 2A, and A. Okay, so 6A, 2A, 6A, 2A, and A. Okay, great. Then we have got P. What's our P? P is actually P is A, 2A, and A. So A, 2A, and A. Okay. A, 2A, and A. Then after which we got PQM. So I need Q. Q is 3A. 003A. So Q is actually just 003A here. Am I right? No, I'm not. My A over 3. Okay, A over 3. Okay, great. So area of triangle PQM, you can take any adjacent side and cross them. So it could be PM cross with PQ, or it could be half MP cross with MQ, or it could be QM cross with QP. It really doesn't matter which one you pick. You should get the same answer. It really doesn't matter. So typically what I'll do is I'm just going to randomly pick a number up, pick one of it. Okay, I'm just going to use Google number random generator. So here what I'm going to do is actually just 1, 2, 3. I'm going to randomize it, just generate, and pick the first equation. So I'm going to use this. Okay, it really doesn't matter which one you pick. So I'm going to find P and PQ. PM will just M minus Q. So this will just be 3A, A, and half A minus A, 2A. That will give us 2A minus A and minus half A, which we already found just now, I believe. Then we have got PQ. PQ would be Q minus P is minus A minus 2A and minus 2/3 A. Okay, so the area of the C minus 2A, 1 minus A, area of triangle PQM is half PM, so it's 2A minus A minus half A cross with minus A minus 2/3 A. You can actually just take the positive side, even though it's very unsightly, right? So you can actually just change all this to positive. But what I'm going to do is actually I'm going to factorize the A out, because A is very annoying. So let's say this is A. A is a constant, right? So there you go. And this will just be A as well. This is A. It is minus 1 minus 2 minus 2/3. Okay, as such. So this a and this a are constant, so you can just bring it out. So this is a squared over 2. Ultimately, what is minus 1 minus half? Cross with minus 1 minus 2 minus 2/3. Okay, there you go. So you're just going to perform cross product here. So you're just going to perform it. And what we'll get here is actually just a square. Just be careful. This is minus 1 over 3. And the subsequent one will be 11 over 6. And the last one will be negative 5. Okay, always check before you move on. So like, so I am going to just, yeah, so there you go. So this case here is a squared over 2. You just need to double check. Okay, cross product is pain. It's really a pain. So key in calculator, this is 1 over 9. 1 over 9 plus 11 over 6 square plus 25. That will be very nice number here. This is 1025 divided by 36. This will just be similar with what we did just now. So square root 36 is just 6. 1025 can be divided by 25, which is 25 and 41. So this case here will give us a squared 2 times 5 over 6 times square root 41. So that will give us 5 a squared over 12 square root 41 square units. Wow, okay, it's just very tedious because you have unknown involved in it. But you have any question or comments, please let us know. Keep practicing and I'll see you in the next question.